Okay, so for this question, it's an ideal op-amp circuit, so pretty straightforward. Again, don't think too hard about op-amps, just stick to the golden rules and you'll be fine, right? So the first thing I always do, it just makes it a lot easier, is actually write out all the golden rules on the diagram, right? So we have two voltages over here, right? So let's label them. Let me call this one V1. Let me call this one also V1, right? Because it's across an op-amp, so they're equal. All right, this one is ground, which means we know this one is also ground, right? Cool. So that's the first golden rule. What's the second golden rule? All currents going into it are 0, right? So let's put 0 going into there, 0 going into there, 0 going into there, 0 going into there. All right, now and this is something that stuck out to me right away. If you ever see this, just keep this in mind. We're trying to get rid of variables, right? We added an extra V1. Is there any way we can get rid of that V1? Well, there is actually. If you look right here, you'll notice that the current going this way is 0, right? Which means the current coming into this branch, right? Because this, if you think about this one branch, right? The current coming in and out both have to be 0, which means there's 0 amps going across this resistor. And what do we know about a resistor that has 0 amps going across it? Well, that always means that there's no voltage drop across it, right? So because there's no voltage drop across this resistor, we know that V1 and Vin are going to be the same thing, right? So we could literally just rename this and call this Vin. And that actually just helps, just renaming it, right? Because that just gets rid of more variables. Okay, cool. So we're still only working with Vin and Vout for now and Va, but we'll get there in a sec. What do we notice on this side? Okay, again, 0 amps, right? Going here, coming out of here, which means there's no voltage drop, which means this also has to be ground, right? So there's a ground on this node, and this node. All right, cool. So let's do some KCL, right? Because that's the easiest way to approach this. All right, starting with KCL here. So Vin minus, right? Where first of all, there's nothing going this way, right? 0 amps going this way, so we don't have to even worry about this branch. We just have to worry about 1, 2, and 3, right? So Vn to Va, right? What's the resistance? 5K, right? Okay, plus Vn to Vout over how many? 50K ohms. Plus Vn to ground over 20K ohms. Right? And this is all equal to 0. Okay, cool. We got one thing down. Now what you'll notice is that we have a variable here, Va, and we want to get rid of that Va. So how do we do that? How do we get rid of this Va over here? That's our goal. Let's think about it. We could try to write a KCL here, but what you'll notice is if we try to write a KCL here, we'll have to add another voltage here, right? That's going to mess with our equations. And we don't want to add more more variables. We want to get rid of variables, right? So what's another way we can represent VA? Well, VA is also connected to this node over here, right? So we can try writing a KCL over here. Since we already know the voltage, that should even make it a little easier, right? So this is ground. So the voltage at this point is 0, right? So you can do some KCL over there. So let's try that. 0 minus VA over, okay, what's this one over? 23K. Plus 0 minus, what's the second point it's connected to? Sorry. It's connected right to V out over 92K. Okay, perfect. Cool. So now we have another equation that also uses VA, and what you're going to notice is we only have two variables in this. So we can literally get this in terms of V out, and then we can plug that back inside here, right? So let's try that. So let me show you what I mean. Let's move V out to the other side. So VA 23 kilo ohms is equal to V out over 92 kilo ohms, right? Next thing we have to do, we want to do it in terms of V out, right? We want VA to be alone. So what we can do next is we can move this over here, and yeah. So VA, negative VA, is equal to 23 over 92. I'm getting rid of these just because, you know, it's the same thing either way. Yeah, okay. Now, you can plug this into your calculator. What you'll find is that it's equal to 1/4, right? So we know that VA is equal to negative 1/4 V out. I also moved the negative sign over, right? Just because. So yeah, so VA is equal to negative 1/4 V out. Okay, cool. Now we have this, so we can just stick this in here. We can get rid of this VA, and then we'll just have it in terms of two variables, right? So that'll be perfect. So let's do that. So we know VA is equal to negative 1/4 V out, right? So let's rewrite this, okay? V in minus what? Minus 1/4 V out, right? So, okay. 5 kilo ohms, right? Plus V in. Now the rest of this we can just copy over. Okay, so we have this massive equation, right? But now we've gotten rid of VA over here, which is good. So what we do next is now we just try to get it in terms of V out on one side and V in on the other side. How are we going to do that? Well, let's split these fractions up. It'll make it a little easier. Okay, 1 over 5. Also, actually, first thing I'm going to do is I'm going to multiply this whole thing by 1K, okay? Because it's just going to make it a little easier. I'm going to get rid of these things. So since they're all over 1K, right, I can just get rid of this K, I can get rid of this K, and I can get rid of this K. All right, that's going to make things a little easier. Now we know 1/5 V in minus 120 V out. Okay, pause for a sec. I meant to say positive 1 over 20. Oops, I will correct myself in a little bit, so bear with me. Plus 150 V in minus 150 V out plus 1 over 20 V in is equal to 0. Okay, lots of fractions. That's fine. Let's wrap this up. So let's keep these on this side, and let's move these over to this side. All right. So first thing is these are all multiplied to V in, right? So we can literally do this plus this plus this, right? So let's do that. 1/5 plus 1 over 50 plus 1 over 20 V in is equal to, okay, now let's move these two to the other side. Oh, sorry, wait, I messed up. So I should have actually written this down as a positive, like that. Okay, sorry. So this one is negative, so when I move it here, it'll become positive. This one is positive, so when I move it on the other side, it'll become negative, right? So we can literally replace this with 1 over 20 plus 1 over 50 V out, right? Now, all we have to do is take this sucker, move it under here. Oh, not with the V. Sorry, let's move the V back. Okay, take this sucker, move it under here, divide it out, right? And what we end up getting is negative 9 V in is equal to V out, right? This you just, no one wants to do this math, so just put in your calculator. You'll get negative 9. And so now we just have to move V in to the other side. And boom, there's our answer. Negative 9 is equal to this. So we're done.